Have you ever wondered how an Amish family, no central heating, no thermostat, no utility company on speed dial, keeps a household of 10 warm through a night that drops to negative 20 degrees Celsius and has done so every single winter for 300 years without fail? The wood stove. The wood-burning stove is the primary heat source in the majority of Amish homes across Pennsylvania, Ohio, and Indiana. It sits at the center of the main living area, typically the kitchen or the front room, and it runs continuously through the coldest months. The Amish do not simply load wood into the stove and walk away. Managing a wood stove through a winter night requires skill that is learned over years. The damper is adjusted to control airflow and therefore burn rate. A fast burn generates more heat but consumes wood quickly. A slower, more controlled burn holds the fire longer and produces steadier warmth through the night. Children as young as 8 or 9 carry firewood and learn to read the stove, to know by the sound and color of the fire whether it needs more wood or less air. That knowledge is passed down inside the household the same way everything else is. The firewood. An Amish household that heats with wood does not buy firewood by the bundle at a gas station. It cuts, splits, seasons, and stacks its own supply. Typically 3 to 5 cords of hardwood for a single heating season, depending on the size of the house and the severity of the winter. A cord of wood is a stack 4 feet wide, 4 feet tall, and 8 feet long. 5 cords is a significant volume of material that requires months of preparation. The work begins in late summer or early autumn. Logs are felled, cut to stove length, split by hand or with a mechanical splitter powered by a diesel engine, and stacked in a woodshed or under cover where they continue to dry. Seasoned hardwood, wood that has dried for at least 6 months, burns hotter, cleaner, and more efficiently than green wood. An Amish family that burns green wood is wasting fuel and generating creosote buildup in the flue. The preparation of firewood is taken as seriously as the preparation of food for winter because the consequences of running short are the same. The masonry heater. Some Amish households use a masonry heater in addition to or instead of a conventional wood stove. A masonry heater is a fundamentally different object from a metal stove. It is built from brick, stone, or soapstone, and it works on a different principle entirely. A metal stove radiates heat while it is burning and goes cold when the fire dies. A masonry heater absorbs heat from a single intense fire and releases it gradually over the following 12 to 24 hours. The fire burns hot and fast, typically 1 to 2 hours, at temperatures high enough to achieve nearly complete combustion. The heat is absorbed into the thermal mass of the brick or stone surrounding the firebox. As the fire dies and the structure cools, it continues to radiate warmth steadily into the room for the rest of the day and through most of the night. A single fire in the morning can keep a room comfortably warm until the following morning. The wood consumption is lower than a conventional stove burning continuously. The emissions are significantly cleaner due to the high combustion temperature, and the heat output is more even. For an Amish family managing fuel carefully through a long winter, the masonry heater is one of the most efficient heating systems available at any price. The kitchen cook stove is the second major heat source in an Amish home, and it is significant not just because of the heat it produces, but because of how consistently it operates. An Amish household cooks 3 meals a day from scratch. Bread is baked. Soups and stews simmer for hours. Canning happens in large batches through the autumn and into early winter. Every one of those activities requires the cook stove to be running, and a running cook stove produces heat, sustained, consistent heat that radiates into the kitchen and the rooms adjacent to it for the entire working day. In a well-designed Amish home, the kitchen is positioned to take advantage of this. Chairs are placed near the stove. The family gathers in the kitchen through the coldest hours of the day, not just for meals, but for warmth. The cook stove in an Amish kitchen is never a single-purpose appliance. It heats water for washing. It dries wet clothing hung nearby. It warms the kitchen through the hours when the main living room stove might be allowed to die back. Some Amish cook stoves are designed with a warming oven at the top, a compartment that stays at a low, steady temperature ideal for keeping food warm, drying herbs, or warming blankets before bedtime. The stove that makes dinner also makes the house livable on the coldest nights of the year. The house itself. The heating system of an Amish home does not begin with the stove. It begins with the house. Amish homes are built or maintained with attention to thermal performance that predates the modern concept of energy efficiency by generations. The walls of older Amish homes are thick, built from stone or heavy timber that holds heat the way a masonry heater holds heat, absorbing warmth during the day and releasing it slowly as temperatures drop at night. Newer Amish construction in many communities includes fiberglass or cellulose insulation blown into wall cavities and attic spaces, providing a modern thermal barrier within a traditionally built structure. Windows and doors are fitted with weather stripping and caulked to eliminate drafts. Gaps in floors and walls are sealed. Heavy curtains, often quilted and made by hand, cover windows after dark to prevent the glass from acting as a radiator that pulls heat out of the room. The number of windows in an Amish home is typically fewer than in a comparable modern house, which reduces the total surface area through which heat can escape. Every design decision in an Amish home reflects the same understanding. Heat is a resource that must be generated and then retained, and the building is the container that determines how well it is retained. Passive solar. One of the least obvious elements of an Amish winter heating strategy is the deliberate use of sunlight. Newer Amish homes in many settlements are oriented with the primary living spaces facing south, a positioning that maximizes exposure to winter sunlight during the hours when the sun is at its lowest angle and most able to reach deep into a room through south-facing windows. During daylight hours on a clear winter day, sunlight entering through south-facing windows strikes floors, walls, and furniture and converts to heat. A passive solar gain that requires no fuel, no stove management, and no effort. The thermal mass of a stone or brick floor absorbs that heat during the day and releases it into the room as temperatures drop in the evening. The strategy is practical and ancient. It predates the Amish community's founding and traces back to building traditions in Switzerland and Germany that the Amish brought with them when they emigrated. In the morning, curtains and shutters are opened early to allow maximum light penetration. As the sun drops and the temperature begins to fall in the late afternoon, curtains are closed and shutters are drawn to trap the accumulated warmth inside. The house has been preheated by the sun before the stove ever needs to compensate for the night cold. In the coldest months, this passive contribution reduces fuel consumption meaningfully and extends the warmth of a single stove load by hours. Kerosene lanterns and propane beyond the wood stove. The masonry heater and the cook stove, Amish families use a range of supplemental heat sources to manage specific situations that the primary systems cannot address alone. Kerosene lanterns are the most widely used light source in traditional Amish homes. The thorium mantle lamps that burn kerosene or naphtha and produce a bright, steady light. These lanterns also produce heat, not enough to warm a room on their own, but enough to make a difference in a small bedroom or a corner of a room distant from the main stove. Several lanterns burning in a room add a measurable amount of warmth to the air. In plainer Amish communities, particularly the Schwarzentruber Amish, kerosene stoves are used as primary or supplemental heating sources, burning the same fuel as the lanterns in a stove designed to radiate heat into a room. In more progressive Amish communities where propane is permitted, propane heaters provide clean, controllable supplemental heat in specific rooms. A propane heater in a bedroom allows that room to be kept at a livable temperature without requiring the main stove to work harder. The fuel is purchased from outside suppliers and stored in tanks on the property. It is not grid-connected and does not violate the Amish restriction on utility dependence. The combination of primary wood heat and supplemental kerosene or propane gives an Amish household flexibility, the ability to concentrate heat where it is needed most on the coldest nights without burning excessive firewood everywhere at once. The quilts. No account of how an Amish family survives a negative 20-degree night is complete without addressing the quilts. Amish quilting is one of the most well-known crafts of the community. Beautiful, precisely made textile works that are sold at markets and displayed in museums. What is less often discussed is their practical function as the primary sleeping insulation system in a home with no central heating. An Amish bed in winter carries multiple layers: a cotton sheet next to the body, a wool blanket above it, one or more heavy quilts on top, each made from layers of fabric with a thick batting of cotton or wool between them. The air trapped between the layers of a well-made quilt is what does the insulating work, the same principle used in modern sleeping bags and down jackets, but achieved through hand-stitched textile construction rather than synthetic fill. A person sleeping under 2 or 3 Amish quilts on a negative 20-degree night is sleeping in a microclimate that their own body heat maintains at a comfortable temperature regardless of what the air in the room is doing. The bedroom may be cold enough to see breath in the morning. The person inside the quilts has been warm all night. Former Amish community members consistently describe the experience of sleeping under heavy quilts in an unheated bedroom as one of the most comfortable sleep experiences of their lives. The weight of the quilts, the complete darkness, and the silence of a house without electrical appliances producing a quality of rest that modern heated bedrooms rarely match. Gathering in one room on the coldest nights of the year, an Amish family does something that modern households almost never do. They gather in a single room. This is not a romantic choice or a cultural performance. It is a thermal strategy. Human bodies generate heat. A room containing 10 people is meaningfully warmer than a room containing 2 people and significantly warmer than a room containing none. An Amish family that concentrates itself in the kitchen or the main living room around the primary stove on a night that drops to negative 20 degrees is reducing the volume of space that needs to be heated, increasing the number of heat sources in that space, and reducing the fuel required to maintain a livable temperature throughout the house. The rooms that are not occupied, the bedrooms upstairs, the back rooms, the workspace rooms, are allowed to drop to much lower temperatures. The cold air in those rooms stays in those rooms because the doors remain closed. The warm air produced by the stove and the family stays in the occupied room. This practice has a social dimension that matters to the Amish as much as the thermal one. Winter evenings gathered around the stove are when quilting happens, when reading happens, when the older children help the younger ones with their lessons, when the adults plan the following day and the following season. The stove is the center of gravity for the household in winter. The family orbits it not just for warmth, but for the kind of sustained, unhurried time together that a house with a television in every room does not produce. No utility bill. The system that keeps an Amish family warm at negative 20 degrees is not a single technology. It is a stack of decisions about the house, the fuel, the stove, the quilts, the windows, the curtains, and the way the family uses the space that work together to produce a livable temperature without any connection to a utility grid. The wood stove handles the primary heating load, managed by a person who knows how to read a fire rather than a digital display. The masonry heater in homes that have one extends the warmth of a single fire through most of the day and night. The cook stove adds heat as a byproduct of the food preparation that would happen anyway. The house itself retains the heat that is generated through thick walls, sealed gaps, and heavy window coverings. The sun contributes additional warmth during daylight hours at no cost. The kerosene and propane fill the gaps. The quilts make the coldest bedroom livable. And the family gathers together in a way that treats shared body heat as a resource rather than an accident. None of these elements is complicated. None requires a specialist to install or maintain. All of them were understood and used by Amish families 100 years ago exactly as they are used today. The utility bill at the end of January in a modern American household heated by gas or electricity can run to several $100s. The Amish household at the same temperature outside has spent nothing beyond the firewood cut in autumn and the kerosene purchased in bulk before the season began. The cold is the same. The system is different, and the system has never failed a single winter.